Hello and welcome to part 2 of the series on infinite series. Today we're going to be talking about index management. So remember that we can only add series if they start at the same index. So maybe k equals a to infinity of ak plus j equals a to infinity of bj. But sometimes two summations don't start in the same place. So if we look at this instance here, we have something starting at a, and then something starting at a plus 2. So this guy here doesn't include the first two parts of what this guy encompasses. So there's two ways we can handle something like this. We can either do an index shift, or we can pull terms out and get them to be the same index. So the best way to understand index shifting is probably to look at an example. So let's look at the summation from 2 to infinity of n plus 5 over 2 to the n. And let's rewrite it with a starting index of 0. So we have n starting at 2, and what we want to do is we want to switch it to something with k starting at 0. Well, the easiest way is to let k equal n minus 2. So that when n is equal to 2, which is our starting point, we're going to switch to k equals 0. And now all we have to do is figure out what n is going to be, and then rewrite everything in terms of k. So if k is equal to n minus 2, that tells us that n is equal to k plus 2. So now we can rewrite our sum as k equals 0 to infinity, because if n is equal to infinity, then k is equal to infinity minus 2. And that doesn't really change anything because infinity minus 2 is still infinity. So we're good on our bounds. Let's look at n plus 5. So n is k plus 2, so we'll switch that to k plus 2 plus 5 over 2 to the k plus 2. And then we can finally rewrite this by simplifying a little bit. K equals 0 to infinity of k plus 7 over 2 to the k plus 2. And that's all that we have for this. The next thing we can do is what I call term pulling. I'm not quite sure what most textbooks call this, but I think this phrase actually demonstrates what we're actually doing. So say we want to take the sum from k equals 0 to infinity of 1 over k squared and move the starting index. So we want to move the starting index to, say, k equals 4. Now we can do this by index shifting, so we can index shift. Or we can just go ahead and pull out the first few terms. So the sum from k equals 0 to infinity of 1 over k squared is 1 over 0. Well, I guess this isn't the best example because we would have to start at k equals 1, because we can't divide by 0. So if we wanted to, we still have the same problem, except we're starting at a different point. So for k equals 1, we have 1 over 1 squared, 1 over 2 squared, 1 over 3 squared, 1 over 4 squared, 1 over 5 squared, and so on. Now, if we want to move our index to k equals 4, we would end at, this is k equals 1, 2, 3, and 4. So we would be starting here and moving over. So what we can do is we can rewrite this as 1 plus 1/4 plus 1/9 plus the sum as k ranges from 4 to infinity of 1 over k squared. Now notice that this guy is actually just the finite sum as k ranges from 1 to 3 of 1 over k squared. And we can rewrite the sum from 4 to infinity of 1 over k squared. And this gives us an important property. So we can say that the sum from k, say, equals 0 to infinity of ak is equal to the sum. We can pick any number greater than 0 in our case, but in general it's any number greater than the starting index to some number n of ak plus k will then start at the next one and go to infinity. Okay, and the important thing to note is that n goes to the next one as n plus 1. All right, so let's go ahead and look at one more example. And we're going to shift the starting index to k equals 5. Okay, and we'll have this sum from n equals 1 to infinity of n plus 1 over n plus 2. So by index shifting, we're going to have to turn 1 into a 5. So what we can do is we can let k equal n plus 4. And that tells us that n is going to be equal to k minus 4. So replacing this, we get our starting index from k now starts at 5, because 1 goes to 1 plus 5, or 1 plus 4, which is 5, to infinity, because infinity plus 4 is infinity, and we're going to replace n with k minus 4. So k minus 4 plus 1 over k minus 4 plus 2. And that's going to give us the sum from k equals 5 to infinity of k minus 3 over k minus 2. And that'll still give us the sum that we started with. The second way is we can pull out terms. And when we do that, remember we have n plus 1 over n plus 2, the sum as n goes from 0 to infinity. And we can just rewrite this as the first term, the second term, the third term, the fourth term, and then we'll have our sum with the fifth and beyond. So this is going to be 2 over 3 plus 3 over 4 plus 4 over 5 plus 5 over 6 plus the sum as k ranges from 5 to infinity of k plus 1 over k plus 2. Note that we could keep this k and these k's as n's, but it doesn't matter because the k's and the n's are just dummy variables. And we can rewrite this in a more concise form. We can rewrite this as the sum as n equals 0 to 4 of n plus 1 over n plus 2 plus the sum as n goes from 5 to infinity of n plus 1 over n plus 2. Both of these, or all three of these, are all the same, and it just depends on the situation and what we need to do in order to further the problem and get a solution. If you have any questions, comments, or concerns, please leave them in the comments below, and as always, thank you for watching.